Hello students, welcome to the PRP lecture videos. In this video, we are going to see that two-dimensional random variables. The topic is continuous random variables. In this previous lecture, we have discussed two-dimensional discrete random variables. So in this video, what is two-dimensional continuous random variables, examples, definitions, and etc. Okay, what is the definition? If a pair of random variables x, y can take all possible values in a continuous range, not just specific points, then x, y is called a two-dimensional continuous random variable. Okay, so here what is all possible values in a continuous range? Let us see one example. We define x equal to temperature in 0 degrees Celsius today and y equal to humidity percentage. So the possible values of x, we denote x might be anywhere from 20 degrees Celsius to 30 degrees Celsius. But right now the situation is changed. Minimum 30, maximum 42 also. So just one example alone. The humidity percentage 40 percentage to 60 percentage. Okay. Now can we guess anyone exactly 20 degrees Celsius or 25 degrees Celsius, 30 degrees Celsius? The temperature may be 25.13 degrees Celsius or 25.02 or 25.15 or x equal to maybe 28.03 or x equal to 29.01. So we can take several values, not only exactly that. No. So from 20 to 30, we can take infinite number of values. Like that, the same for y also 47.82 percentage or 42 or 43, 45, whatever it is. So between these numbers, we can take infinitely many more values. That's why x, y can take all such possible combination in the rectangular region. In the rectangular region, that's why it is called continuous random variable. Okay. Now the definition is joint probability density function. Okay. So there we have seen joint probability mass function. So here density function, so joint probability density function. So f of x, y. What is the condition? Non-negativity. Total probability is 1. Probability over a region R. So probability over a region R. So non-negativity. Each and every f of x, y greater than or equal to 0 for all x and y. So when we take any values of x and y, all f x, y greater than or equal to 0. Total probability is 1. Double integral over r square f of x, y dx dy equal to 1. In other words, how we define, integral minus infinity to infinity, integral minus infinity to infinity, f of x, y dx dy equal to 1. Okay. Now what is the probability over region R? P of x, y belongs to R because both x and y values are taken from real numbers. So double integral over R, f of x, y dx dy. Okay. Now see the simple example. The random variable x, y has the PDF f of x, y equal to 8x square into 8 minus y. See the range defined x less than y less than 2x, 0 less than or equal to x less than or equal to 2. Find k value. Okay. So what is the first condition? F of x, y greater than or equal to 0. F of x, y greater than or equal to 0. So in this interval, what is x limits? 0 to 2. Substitute here 0 not 0, 2 not 4. So highest upper limit is 4. Okay. So here x order limits 0 and 2. Okay. However it is, when we substitute from the positive values and from the positive values substitute here, you may get f of x, y greater than or equal to 0. So let us find what is k. So based on greater than or equal to 0, we have to find k. So first condition, non-negativity is clear. Second one, not clear because we don't know k value, So using the second condition, total probability value equal to 1. So what is the formula? Double integral over R f of x, y dx dy or dy dx equal to 1 equal to 1. dx dy means we are using horizontal strip. Dy dx means we have to evaluate the region by vertical strip. Okay, right. So first integral 0 double integral. What is the function? Kx square 8 minus y and dy dx. So y limit x to 2x, x to 2x, x limit 0 to 2, x limits 0 to 2. Okay, so first we have to complete the inner integral first. Okay, so k is the constant, x square bring to that side also, but this integration doesn't affect x square because with respect to y. So x square take as it is. Now 8 into integral dy value equal to 8y minus y integration y square by 2. So limit upper limit 2x, lower limit x. Okay, x and 2x. So substitute y, replace y by 2x minus x and replace y by 2x square, 2x whole square, 4x square and minus y value x, x square. That's all. So I am keeping x square as it is. I am replacing y by upper limit and lower limit minus replacing y square by upper limit and lower limit. The rest of the integration as it is and right hand side equal to 1. Okay, simplifying this 8x 2x minus x, x, 4x square minus x square 3, 3x square divided by 2. Okay, now multiply x square inside the bracket. Now we keep k outside as it is. Okay, so 8x into x square 8x cube, x square into x square x power 4. So minus 3 by 2 x power 4. See, 8x cube minus 3 by 2 x power 4 into k dx equal to 1. Now with respect to x cube integration x power 4 by 4, x power 4 integration x power 5 divided by 5. Now 2 into 5 10, cancel by this one 2. So 2, apply the upper limit lower limit x power 4, 2 power 4 minus 0. Lower limit 0 only now, so no need to substitute. X power 5, 2 power 5 minus 0. Okay, so only 2 power 5. So 2 power 2 in power 1, 2 power 4, 2 power 5. So take 2 power 5 common from the two steps, 1 minus 3 by 10. So 1 minus 3 by 10 naga 10 minus 3 divided by 10, answer 7 by 10. Okay, 2 power 5, 2 into 2 into 2 into 2 into 2. So 4, 4, 16 into 2, 32. So 32k into 7 by 20 equal to 1. So k value equal to 5 by, simplify this one, 5 into and 16 into. So 5 by 16 by 7 equal to 5 by 112. Okay, so since k value is greater than 0, f of x comma y, our assumption is correct, greater than or equal to 0, then only it has the PDF. Okay, right. Now find the marginal PDF of x. Have you remember how we found px of x and py of y? Have you remember? Well, we find the marginal probability mass function of x summing over y. We find the marginal probability function of y summing over x. The same way obtained by integrating the joint PDF over all possible values of y. When it is required for x, over all possible values of y. When it is required for y, overall possible values of x. That is the concept. Okay, so fx of x equal to integral minus infinity infinity f of x comma y dy. When marginal PDF of y, fy of y equal to integral minus infinity infinity f of x comma y into dx. Okay, let us see one example. If the joint probability density function of a random variable x and y is given by f of x comma y equal to x cube y cube divided by 16. What is the limit? 0 to 2, y limit 0 to 2, 0 otherwise. Find the marginal functions of x and y. Find the marginal functions of x and y. Now write the function as it is. The given joint PDF of f of x comma y equal to x cube y cube divided by 16. Write the limits also. Okay, first let us find what is the question. Find the marginal functions of x and y. So fx of x equal to integral f of x comma y dy. What is y limits? Here both x and y limits 0 to 2. So f of x comma y and dy limits 0 to 2. So f of x comma y equal to x cube y cube divided by 16. With respect to y cube becomes what? Y power 4 divided by 4. Already we have 16, so 16 into 4, 64. X cube as it is. Okay, so limit 0 to 2. See, x power 4, y power 4 by 4, limit 0 to 2. So upper limit 2, lower limit 0. So 2 power 4 minus 0, 2 power 4 value equal to 16. So x cube by 64 into 16, cancel from 4. Okay, so x cube by 4. Since x and y both are having power 3 and both having same limits, we can write easily what? F of y equal to, here in terms of x cube, in terms of y means y cube divided by 4, limit 0 to 2. Okay. Now, what is the probability value of? Suppose the question is given probability of the x with certain limits. What we have to find? So x limit is given a to b. So x limit is given. What is y limit? Minus infinity to infinity. Okay. So using double integral, we keep this y limits as it is. Only we change the x limits alone, a to b. Okay. Now already we know that integral minus infinity to infinity f of x comma y dy equal to fx of x. That is what? Marginal probability density function of x. Like that for y also. Since y limit is given, for example, probability of minus infinity less than x less than infinity. Y limit is given c less than or equal to y less than or equal to d. Okay. So here integral minus infinity infinity f of x comma y dx equal to fy of y. Okay. So whenever they ask probability of y, use this formula. Probability of x, use this formula. Okay. Now the conditional probability distribution. So f of x given y. As usual, f of x comma y divided by f of y. So there we have seen p of x by y equal to p of x comma y divided by p of y. Like that is the same. Here joint density function, marginal probability function. Here note that density function greater than or equal to 0, but in this case strictly greater than 0. Like that, the conditional probability of y given x equal to x is denoted by f of y by x equal to f of x comma y divided by fx of x. Here also, the marginal probability density function of x should be greater than 0. So we should not take equal to 0. Okay. Let us see one example for understanding the concept. Okay. So what is f of x comma y? 8xy. What is the limit? 0 less than x less than y and less than 1. So to separate x limits y separate for x less than y. For y, x less than y less than 1. Okay. So marginal of y, f of y equal to integral. What is x limit? 0 to y. So 0 to y, 8xy dx. Okay. So in terms of x only now. So 8 is a constant, y is a constant. Take it outside. 8y into 0 to y, x into dx. Okay. So answer is 8y x square by 2 limit 0 to y. So here 2 and 8 cancel by 4. Cancel by 4 and apply the upper limit y square minus 0. So answer y square alone, y into y square equal to 4y cube. Limit 0 less than y less than 1. Since x power 1 and y power 1, we cannot take directly f of y because x limits different, y limits different. See, we should find f of y later. Marginal function of x. So fx of x equal to integral x to 1. Integral x to 1. So 8xy dy. Okay. So in terms of y, so let us take 8x separately, 8x into integral x to 1 y dy. So y square What is the answer? 8x y square divided by 2, limit x to 1. X to 1. So 2 and 8 will be cancelled by 4. Okay. Y limit first to 1. 1 square minus, replace y by x, x square. So 1 minus x square. So already we have cancelled 2. So 4x into 1 minus x square. What is the limit? 0 less than x less than 1. Okay. Right. Now, the conditional probability density function of x given y equal to y. So, f of x given by y, that is f of x comma y. What is the formula? F of x comma y divided by f of y. F of x comma y equal to 8 into xy. Now, what we have found? F of y 4y cube. So, 1y and cancel. So, and also 4 and 8 to 2x by y square. So we can write fxy like this, or simply we can write f of x comma y equal to 2x by y square. Okay. Now conditional probability density function of y given y x equal to x, that is f of y by x. Okay. The same formula, f of x comma y divided by, here denominator x only, no, so f of x. Substitute here, f of x comma y equal to 8xy. F of x equal to 4x into 1 minus x square. So cancel 1x, x and 4 and 2. So 2y divided by 1 minus x square. What is the limit? X less than y less than 1. Okay. Now another one. Independent continuous random variable. There we have seen p of x comma y equal to p of x into p of y. Like that, here too, for a continuous random variable, f of x comma y equal to f of x into f of y for all values of x and y. Not only for some specific values of x and y, for all values of x and y. Okay. So that means the joint PDF can be written as the product of the marginal PDF. Okay. Let us take the previous example. There we have seen f of x equal to 4x into 1 minus x square and f of y equal to 4y cube. What is f of x comma y? So let us check whether independent or not. Okay. So f of x comma y equal to f of x into f of y. Then we can say that independent. Okay. So what is f of x comma y? That is nothing but 8xy. F of x 4x into 1 minus x square. F of y 4y cube. Simplification this 16 into xy cube by into 1 minus x square. So both are not equal. So f of x comma y not equal to this. So not independent. Let us see another example. Important one. F of x comma y equal to x plus y. X limit 0 to 1, y limit 0 to 1. See, x power 1, y power 1, same degree and same limits. In this case, we can easily find out f of x, f of y. See, check whether x and y are independent. Given joint PDF, f of x comma y equal to x plus y, limit 0 to 1 and y limit 0 to 1. Now the marginal function of x. What is f of x? What is the formula? Integral f of x comma y dy. Dy limit 0 to 1. F of x comma y, x plus y. So with respect to y, x is a constant. Integral dy equal to y plus integral y dy value y square by 2. Limit 0 to 1. Replacing y by 0 and 1. What is the answer? X into 1 minus 0, 1 by 2 into 1 minus 0. Okay. So x into 1, x plus 1 by 2 into 1, 1 by 2. Similarly, we can easily find out the f of y, y plus 1 by 2, since x limits and y limits both are same. Now, what is f of x comma, sorry, what is f of x into f of y? X plus 1 by 2 into y plus 1 by 2. Simply multiplying this, x into y, xy, x into 1 plus 2, xy, plus x by 2 plus y by 2 plus 1 by 4. Okay, simplifying this, we can get this answer. This is not equal to, what is f of x comma y? x plus y. Since both are not equal, x and y are not independent. Clear? Thank you. Let us see another video.